So now I'm going to continue with my production function example to derive what's called the Production Possibilities Frontier, or PPF. A lot of books sometimes skip the introductory part and don't show where it comes from, but there's a way to show how two production functions combined with a pool of labor that can be shared between the two can actually make the PPF. It explains the choices by which you give up one opportunity to do the other opportunity, the opportunity costs involved, and it shows how there's a price involved with the economic decision. Now, labor doesn't go into the PPF. It's sort of assumed that it's there, but really the thing we graph is one activity and another activity and the quantities of both. So I've got my original numbers, but what I've done is I've extended it, and I've got this equation, labor in X and labor in Y equals 6. I have 6 workers. I can use them all in one industry or none in one industry. And if you were to take the split, you would say 0 in X, 6 in Y. So my two industries, X and Y, are going to have the same 6 workers used in both. And so two workers in industry X means 4 in industry Y, 5 in 1, 3 in 3. All the way to everything in X and nothing in Y. So that's what you're trading off. If you move workers out of X to make Y, you're giving up X to get Y. And so this gives us some sort of a price. Now, what I did was I made an identical industry that's upside down, meaning if I have no workers in X, they're all in Y, and because I have numbers already for the relationship, I simply start here and go backwards. This is where everything's in Y, this is where nothing's in Y. So that's how they're related. The 6 workers go into both. And when you graph the PPF, you really only graph these 2 columns. These are just assumed, they're never drawn. So if I were to look at this equation, I could have 0x, 10, 20, 30, 10, 20, 30. I could have 0x all the way here. Remember which axis is which. And I would have 30y. All right? If I start at the other extreme, I would have 30x and 0y. And I can start from whichever corner I want. So I can say, what about 29y and 12x? So that would be 29y and 12x. What about 27y and 20x? Or 24 and 24? And all the way across till I get a curve that looks something like that. Now, with only 6 or 7 points, it's going to be kind of jagged, but I made it a curve. This is where the PPF comes from, is that you're assuming that there's 2 production functions, each with a curve, that combine into a single 2-sided PPF. Now, the thing I like about the PPF is that it shows a couple of things. It shows borders or boundaries. It shows the limits of how much can be produced. And so maximum production can only be on this curve right here. Anything inside is inefficient. And anything on here is efficient. And anything over anywhere in space in this whole range is unattainable. If we only have 6 workers, we can't make 30 and 30. We can only make 30 and 0. So this point is if you had 12 workers, but you don't. You only have 6. The only way to reach this point is to grow. If you were to have economic growth, you would expand the PPF to be a larger curve. So given technology, given capital, given land, given labor, given all resources, you simply have this curve. You don't want to be inside because you're wasting resources, and you can't be outside. But anywhere you want on here is fine. So this gives borders and boundaries. Another thing that it gives you is trade-offs. So this is extremely important, is that you can choose any point on this curve, but which one do you choose? It has to do with the relative price. You can choose based on how much you're giving up to get one of another product. So you can look on this graph. If I am making 30x and I want anything from y, because I've got 0y, I can give up 1 unit of x. This is my cost, and my benefit is 12 units of y. So the cost is 1 and the benefit is 12. If you go over here, it's a little less lopsided. So this is a benefit to cost ratio of 12. Over here, you can give up 3 to gain 4. So it's not 12, it's close to 1. So it's falling. And over here, you're giving up 12. Your costs are 12 and your benefits are 1. So it goes all the way to 1 over 12. So that's the idea, is that you can look at this as rising costs and falling benefits, whichever direction you go. You can actually make a ratio of it. And if you remember rise over run, you can look at, if you go to 29, rise over run. That's the same as a slope. So as I go from point to point to point, I find that my rise over run is constantly changing, and it's changing in a way that reflects the rising costs and falling benefits that we've done before. Now, if you take rise over run and you get a slope, you can actually use the slope on this curve as a measure of costs and benefits. In this case, it's a measure of price. Here, 12y costs you 1x. That's your benefit in terms of your cost. Here, 1y costs you 12x. And so there's no money in this economy, but you can give up one product to get the other. That's the price you pay. And so it's trade-offs in terms of some sort of a price. And it's a constantly rising price, depending on where you go. So if I pick a point on here, I can make the slope of that triangle, sometimes known as a tangent line if it's at a single point. This is my relative price. And as I move from point to point, I find that the steepness goes from flat to fairly steep to extremely steep. That's like saying that the price is getting more expensive. It's relatively cheap to gain product Y over here. I give up a very low amount to gain a huge amount. That's a huge benefit for me with a tiny cost. But as I go, this number falls constantly in one direction and rises in the other. And so you wind up here with a huge cost and a tiny benefit. If you look at this triangle as cost and benefit, which is exactly what it is, the rise is what you're giving up. You get less and less X. The benefit is what you're gaining. You're gaining a different amount of Y. And so as you move, what you're giving up grows and what you're gaining shrinks. So that's extremely important, for example, in international trade, because you can actually talk about countries trading at different prices, choosing to produce and sell abroad. So understanding the slope or the tangency line as a relative price is important in other classes. But again, it's extremely important to understand that this represents a cost-benefit decision, and you're choosing where to operate based on where you want to be. If you say, well, I'm not comfortable giving up a huge amount just for this last unit of Y, you're basically saying that you don't want to completely specialize. You don't want to completely produce product Y. You're willing to give up a little bit. You're willing to keep a little bit of X. You're willing to not have that last unit of Y because you know it's extremely expensive to do that. All right, to sum up, this is the boundaries. All right, it actually is derived from two production functions. If you combine them subject to one single labor force that can be switched, you can give up workers here to gain output in the other industry. But because you're giving up workers, you're actually giving up output to gain output. So you're constrained by your workers as well as your capital and land and technology, so you're only able to produce along this line. It's bad to produce at an inefficient point. It's impossible to be unattainable. Therefore, any point here is fine, as long as you're willing to pay the price. Because the price is rising, you might choose not to operate in a corner, but you might choose to operate somewhere in the middle. Thank you.